application of an inverse trig function. Let's say I have a circle with a radius of 10 feet, and then I've got a point out here that is exactly 40 feet from the edge of the circle. This line here is called a tangent to the circle. That's a geometry term. It means a line that just grazes the circle at exactly one point. I'm going to call this central angle theta, and I'm going to call the arc length marked off by that central angle S. My goal in this problem is to find S. Find the length of that arc. Well, I need to use a little bit of geometry and then some trig to accomplish this. I do have a formula for arc length. We have learned that the length of an arc is equal to the radius of the circle times that central angle, as long as we measure that central angle in radians. Well, I have the radius of the circle already, so obviously if I can just figure out what that angle is, I'll be all set. The one fact from geometry that we have to remember is that when you do have a tangent line to a circle, where it intersects the radius, that forms a right angle. So I know that this is a 90-degree angle. That's great because it means I have a right triangle in this picture. Let's see, how many side lengths do I know in this right triangle? Well, here's a side length. I know that that's 10. Do you see that I also know this length? Part of it is 40. The other part is another radius of the circle. This is 10, another 10 feet right there, which means the whole length of this segment is 50 feet. Well, that's really all I need to write an expression for angle theta. I can see that the cosine ratio of angle theta would be the 10 feet divided by the 50 feet. 10 is the adjacent leg to angle theta. 50 is the hypotenuse. That simplifies to 1/5. Well, how am I going to solve this little equation? The great thing is, clearly theta is an acute angle. It's an angle in a right triangle, which means it's in my restricted zone for inverse cosine. Theta will then be the inverse cosine of 1/5. In other words, theta is the acute angle whose cosine ratio is 1/5. Well, I can fill that into my formula over here. In order to find the length of that arc, I just need to take the radius 10 and multiply it by the angle cosine inverse 1/5. I can do that quickly on the calculator. I am in radian mode. That's important. The formula only works for an angle in radians. And so I will type 10 times cosine inverse of 1/5. And my answer is about 13.7. Our units are in feet, so 13.7 feet. We're saying this length right here is about 13.7 feet. Thanks for watching.